Hello, and welcome to Episode 5 of the Gnosis and Science podcast. I am your host, Nicholas Thumb, and today's episode is Free Will and Mathematics. In this episode, I would like to look at how the concepts discussed previously, from the infinite dividing itself into smaller fractal expressions, free will and lower density realities, can be seen mirrored through the lens of not just physics, but also mathematics. We will look at how the axiom of choice and related mathematical structures like Cantor's diagonalization, well ordering, and the Banach-Tarski paradox can be mirrors and mechanics of free will and consciousness across infinite possibilities and higher dimensional realities. By mapping the flow of choice through layered infinities, I would like to show that each selection is an actual trajectory within a field of potentiality, governed by intrinsic rules rather than some arbitrary imposition. The infinite branching of paths mirrors the structure of energy and consciousness as it moves through higher density layers, while the four primary directions correspond to archetypal guardians maintaining coherence across these dimensions. Drawing on Plato, Hindu cosmology, and scriptural references, I'd argue that free will is not symbolic, but embedded into the architecture of reality itself. By connecting these abstract mathematics to consciousness, we can provide a framework for understanding how human agency, probability collapse, and spiritual evolution emerges as measurable structured phenomenon. In this section, I'm exploring how the axiom of choice, a mathematical principle about selecting from infinite possibilities, mirrors what we call free will. It shows that even in a universe governed by laws, we still participate in shaping reality through our choices. Here, we can give people a framework that makes free will not just a belief, but something that can be understood both logically and also spiritually. So, the axiom of choice, often viewed as a purely abstract principle in mathematics, becomes deeply relevant when considered through the lens of human existence. By exploring how it mirrors the nature of free will, we can gain a unified framework that bridges philosophy, science, and spirituality, and reveals how the fundamental structure of logic already encodes the possibility of choice and thus consciousness itself. In this way, the axiom of choice serves as a keystone, offering insight into the mechanics of reality and how our agency arises within it. But beyond theory, what does this mean for you? At its heart, the axiom of choice shows that no matter how complex or infinite the possibilities before us, a choice is always available. This mirrors our lived experience. Even when life feels overwhelming or predetermined, the power of decision, however small, is the spark that shapes our path. So understanding this principle can shift how we see our challenges and our opportunities and even time itself, reminding us that free will is not an illusion, but a built-in law of existence. So there are an infinite amount of natural and square numbers. So natural is 1, 2, 3, 4, 5, and square numbers is like 1, 4, 9, 16, 25, and so on. With this, Galileo thought that terms such as greater than or less than do not apply to infinity. This is how most people understand the concept of infinity to this day. But in 1857, a man named Cantor thought, what if there are two sets of infinity that don't line up with each other? Would they be different infinities? He compared a set of natural numbers, so 1, 2, 3, and 4, and a set of numbers between 0 and 1. So this would be anything from 0.00005 or 0.007 or 0.06, anything between 0 and 1. So think of these sets as being written down parallel to each other, with a list of natural numbers being aligned with the real numbers between 0 and 1. So there's two columns. On one column is the natural numbers going 1, 2, 3, 4, 5, 6 down. And then the other column are the numbers between 0 and 1. So the ones I had previously mentioned, on down infinitum. So we're going to go and move on to what is known as Cantor's diagonalization proof. So these numbers between 0 and 1 can be written in any order, as there is no smallest. So if there are an infinite amount of numbers on this list, all Cantor has to do is create a completely new one by adding a +1 to the first digit. So if it was 0.0005, it would be 0.1005. And then the next one would be, if it was 0.027, it would be 0.037, so on and so forth. So he's just adding one and moving over one digit as he moves down the list, and then he subtracts one if he comes to an 8 or a 9, and this avoids duplications. So this newly created number is now different from every single number on this infinitely long list by at least 1. So this shows that there must be more real numbers between 0 and 1 than natural numbers, showing that there are different scales of infinity, as they're both as all of these are infinite, but they're at different scales of expression. So number sets like square numbers, integers, and rational numbers are called countably infinite, as they can be perfectly paired with natural numbers. Then there are uncountable infinities with complex numbers, which can't be counted one-to-one with natural numbers. So Cantor's diagonalization proof can be understood as an expression of how consciousness navigates infinite potentialities. So each real number constructed along the diagonal isn't just a mathematical abstraction, but it represents a path of selection among uncountable possibilities, reflecting the structure of choice across infinite branching realities. So the diagonal itself is a trajectory through infinite space, ensuring that every selection is distinct and independent and corresponding directly to the flow of conscious decision making. The procedure demonstrates that even within an infinite system, unique paths emerge naturally, guided by these rules rather than arbitrarily arising. And this process mirrors the dynamic of energy or consciousness as it descends through different layers of density of reality. So just as the cycloid curve represents the fastest descent from higher to lower densities, Cantor's diagonal constructs a number that necessarily lies outside all previous enumerated possibilities. So in this sense, this mathematical structures like the diagonalization proof are an expression of how consciousness interacts with infinity. So each choice and selection is moving through a field of potentiality. And the axiom of choice formalizes this, ensuring that at every level, be it countable or uncountable, consciousness can act, selecting elements from infinite sets and shaping reality. So, viewed this way, the diagonalization proof is not just an abstract lesson, but encodes the geometry of choice and the flow of consciousness as it expresses itself at different scales. Now we'll look at what's known as well ordering. So next, Cantor wanted to prove that these infinite sets that can't be counted could still be placed in some sort of order, what we call a well order. So a set must meet two conditions to qualify as a well-ordered infinite set. One, it must have a clear present starting point, and two, every subset must have a clear starting point. For example, in a well-ordered set, natural numbers from 0 and on have a clear starting point, or a subset from 3 to 7, or integers from 0 to a positive infinite or a negative infinite. Cantor's concept of a well-ordered set, in which every subset has a clear starting point, maps directly onto cycles of reincarnation described in many spiritual traditions. So each individual life or existence functions as an element within a larger structured set of infinite possibilities. So just as a well-ordered set guarantees that every subset can be approached in a sequence from a defined starting point, so too does this cosmic framework of reincarnation ensure that every conscious being follows a traceable path through successive lives. So this establishes a kind of structural coherence across what would otherwise appear to be an uncountably infinite expanse of experience, both across multiple lifetimes, but also each individual incarnation. Because again, you can take any path you want in this life, you just see the one that you can view through linear time. So in Hindu and Buddhist cosmology, these cycles of birth, death, and rebirth aren't random, but are organized according to karma, dharma, and spiritual progression, reflecting this same principle that governs these well-ordered sets. And the parallels extend beyond merely sequential ordering. So in Norse, Greek, Egyptian, Hindu mythology, these pantheons of gods and their realms may be viewed and considered as subsets within a larger multiversal order. So each pantheon is like a subset of a well-ordered set and has a specific starting point, an internal hierarchy, and certain rules of interaction. So consciousness itself navigates through these internested layers, moving from one subset of experience to another, while also anchored to the broader structure of reality. In this way, well ordering isn't just an abstract mathematical tool, but an expression of infinite temporal cycles, divine archetypes or subconscious archetypes, and consciousness itself as coordinated. The axiom of choice guarantees that selection is always possible at every juncture and ensures that every soul can choose its path through these layers, echoing the same principle of agency observed in human free will. Later, Ernest Zermelo, a German mathematician, noticed that he produced a paper titled "The Proof That Every Set Can Be Well Ordered." And he found that Cantor had a mechanism he had used unconsciously and instinctively everywhere in his work, but had never actually explicitly stated. So Cantor assumed he could make any number of choices at once from any set, including uncountable infinities. But it's an assumption in math that is created on rules or axioms. These are statements we accept as true without proof. So if this sounds familiar to the idea of faith, it's because it shares the same definition. So Zermelo realized that Cantor's assumption needed to be formalized into something that held up in a system of proof. And so the axiom of choice was created, which states if you have infinitely many sets and each set is not empty, then there is a way to choose one element from each of those sets. This is from Professor Alex Kontrovich, and he's from Rutgers University and Institute for Advanced Research and Study. So if we're choosing from infinitely many sets, including uncountable ones, we need a rule, the axiom of choice. So we can't define the rule, only that we are making the choices simultaneously from all sets, from all possibilities. Now we will look at the Banach-Tarski paradox. So in 1924, Stefan Banach and Alfred Tarski showed that if you took a sphere and split it into 5 separate pieces and you rotate them, you could reassemble them into 2 spheres, each identical to the original in volume. So you could keep doing this and essentially get an infinite number of spheres from the one original one. And if you can think of this in a graph form, imagine you can move in 4 directions, up, down, left, and right. And each time that we move, we can choose to move in any other direction as long as we don't go back. So we end up with something that looks like, think of a very boring snowflake. So if we do this enough, we get an infinitely branching graph that we can break down into different sections. So we can divide it into 4. Let's say we take the left section and we move it back just 1 step. And then we can take the upper and the lower sections and see that they align with the original ones, leaving that one missing section, and we can just add that back in. So you can do this with any section, meaning you're going to create the same graph in 4 different ways. So if you apply this to a sphere that can rotate in 4 different directions, so you start with a single point and rotate the sphere. And with each point being colored, depending on which direction you move. So if you do this a countably infinite number of sets, so this sphere will have a uncountable infinite amount of points. And if we repeat this process, we start at a new point. So we bring in the axiom of choice to get a new starting point. So even though we can't say how it is we're choosing them, we are choosing them. And once we've colored this ball with these different points and movements, we can split it into 5 sections. The first is the starting points, and the others are based on the final rotation that we've used to arrive at the endpoint. Now, these groups can be treated just like those sections on that very boring snowflake graph that I was hoping you could imagine in your head. So we can take the group that ends in a left rotation and rotate it to the right, and then add the group that ends in a right rotation, and then we have our original sphere. And we can do this again, making extra moves to account for like the starting points. So we can take the group that ends in a right rotation and rotate to the left, and then add the group that ends in a left rotation, man, you get another sphere. So applying this idea to the anti-de Sitter space in the conformal field theory, where all information is preserved along a event horizon, we can see how these branching alternate paths lead to infinite choice. From the smaller scale expression of the alpha and omega point that we all embody as an expression of the infinite, from our birth to our eventual death, and to a larger scale of the creation of everything and all that is, and then its eventual destruction. So later Tarski said squaring a infinite set would not increase its size, and after submitting his work to a journal in Paris, the editor responded, "Nobody's interested in the equivalence of two false statements." And then after sending it to another editor, they said, "Nobody is interested in the equivalence of two obviously true statements." While later in 1938, Kurt Gödel proved that there is a world where all axioms of set theory hold true, including the axiom of choice. And then in 1963, Paul Cohen proved there is a world where all axioms hold true except the axiom of choice. So as long as the other axioms hold true, the axiom of choice can neither be proven or disproven. So this is how free will works. The axiom of choice is essentially your belief. If you have a belief, I can't prove or disprove that it is wholly incorrect. So let's say you want to work with certain deities, then yeah, you can do that. It might not be a very good idea, but you can do it. Or you might hold a belief that the earth is flat, or that certain subsets of humanity are better than other ones, or anything. And again, I don't know why I joined that one right after flat earthers. Sorry, I hope that's not like coming out as like some sort of bias I have. But point being is that just because something is provable in one sense doesn't mean it inherently invalidates the other person's belief. It might mean that they're not working with the full picture, but it is still their free will and belief to choose that. It's like a multi-layered jigsaw puzzle of understanding. So next, let's look at the four directions and the four guardians, known as the heavenly kings in Buddhism, or the four archangels associated with the cardinal directions. So in constructing this infinite graph, the four primary directions of up, down, left, and right aren't just choices, but correspond to the four cardinal directions, which, as I previously mentioned, are associated with the heavenly kings or guardian archetypes from either Christianity or multiple spiritual traditions. So these guardians serve to maintain balance and order within their respective domains, ensuring that each aspect of creation unfolds coherently. And again, we can look back at what I had discussed in the previous episode about the four rivers flowing into the garden from Eden as spatial axes and not literal rivers in a geographical location. So as we move through this graph along one of these directions, each step mirrors the influence of one of these guardians, guiding the flow of energy and consciousness, preserving structural integrity within a otherwise infinitely branching system. So each rotation or reorientation of this graph can be seen as a enactment of these guardians' roles. So just as the Banach-Tarski paradox allows for a sphere to be split and reassembled into multiple configurations without losing its original form, the guardian's oversight provides a framework that maintains coherence and continuity. So even if a section of the graph shifts or a new starting point is chosen, representing a selection from an infinite set, so we choose something, this overall structure will remain harmonious, reflecting both a kind of mathematical necessity and spiritual order. So this alignment suggests that infinite possibilities are not chaotic, but constrained by higher order principles, whether expressed in mathematics or cosmology. Furthermore, each branch, rotation, and reassembly corresponds to a choice, with the guardian's directions providing a functional map for these selections. The graph then is not just a mathematical illustration, but a reflection of how higher dimensional forces and consciousness organize and guide infinite possibilities. So the four directions and their guardians actually anchor this infinite branching, ensuring that every path taken before reaching resonates with a underlying order of a system. It's a direct manifestation of structure emerging from choice. This structural and symbolic mapping will also connect to the concept of free will. Just as the guardians ensure coherence across infinite branches, the axiom of choice formalizes the principle that selections can be made infinitely from many possibilities, and each individual's decision in life, like each choice, is a direction on this graph and requires a implicit mechanism to determine a starting point and a next step. So by recognizing how these infinite possibilities can be navigated coherently, both mathematically and spiritually, we can see that free will isn't arbitrary, but a capacity encoded into the architecture of reality. So with these four directions and rotations of a sphere, once again we can put this back into the idea of the anti-de Sitter space and conformal string theory. So these four spatial axes being mentioned in the book of Genesis, with the four rivers that flow from the Fishon, Gihon, Hikol, which is the Tigris, and the Euphrates, splitting into four headwaters from one source. And looking at real world examples that happen, this happens like a total of 0 times. You don't just split the river. So we can assume that these rivers aren't referring to like physical locations, as I had mentioned before, but that they flow from Eden, which is elevated in relation to the garden. So it would make sense that Eden is a higher reality along this scale invariant axis. Well, the source, which is the alpha point of pure potential, it's the creation of everything. It's the throne of God, or unity consciousness. So in Revelation 22, 1 through 5, it says, "The angel showed me the water of life, bright as crystal, flowing from the throne of God and of the Lamb through the middle of the street of the city. Also on either side of the river, the tree of life with its 12 kinds of fruit, yielding its fruit for each month." So these rivers aren't just literal rivers, but spatial axes within space-time, each governed by an angel or an aspect of God consciousness that isn't attached to itself in the egoic sense. So they act as guardians to facilitate the plane out of free will. And as we ascend along the scale invariant axis to higher realities or heavens, we are gaining access to more spatial axes or higher dimensions. So these are higher densities of reality, all of which are originating from source consciousness. I hope you found this video interesting. Leave a like if you liked it and a comment. And if you want to know more, I have a course on teachable.com. And I'll catch you in the next episode.